This is the 29th LeetCode challenge, and it is called Divide Two Integers. Given two integers, dividend and divisor, divide two integers without using multiplication, division, and mod operator. The integer division should truncate towards 0, which means losing its fractional part. For example, 8.345 would be truncated to 8, and negative 2.7335 will be truncated to negative 2. Return the quotient after dividing dividend by divisor. Assume we are dealing with an environment that could only store integers within 32-bit signed integer range. For this problem, if the quotient is strictly greater than 2 to the power of 31 negative 1, then return that. And if the quotient is strictly less than negative 2 to the power of 31, then just return that. Okay, so if the dividend is 10 and the divisor is 3, it outputs 3 because when you divide that it does 3.333, etc. So move the decimal place and it's just 3. 7 divided by negative 3 is negative 2.33, so you move decimal place and it's negative 2. Okay, so the divisor can't be 0. Okay, so let's get started. I think the way to do this is by using addition with the divisor. So you have the dividend and use the divisor to just add. So if you add it once, okay, actually I'll just get started in it. It's hard to explain what it is. So something that we should first check is whether they are positive or negative. So bool is positive, as in whether the output should be. So for this it will be positive if both dividend and divisor are positive, or if they're both negative. So dividend greater than 0 and divisor greater than 0. So if they're both greater than 0 or they are both less than 0, then we know it's positive. And then I guess easiest thing to do first, we will just make them both positive. So equals math.abs dividend, and then do the same thing for divisor. Now something that we can do is, because we're truncating it, no, you don't need to do all that. If divisor is greater than dividend, we just return 0, because I mean, if the divisor is greater, it's going to be a fractional number, so then you just need to return 0 straight away. So we have that out the way. Otherwise, we'll just do int total equals 0, and okay, what's it called? The thing that we are returning, the quotient. So int quotient equals 0, and we'll do while total is less than dividend, total plus equals divisor, and then quotient plus plus, then return quotient. So I think that's all that has to be done. So let's say we have dividend 10, actually we'll do dividend 9 divisor 2. So it starts up at 0, we do plus equal, which makes the total 2 and the quotient 1. We then do 4, 2, 6, 8. It'll go to 10 and 5, but then now its total is greater than dividend, so then we're returning the quotient, which will be 5. So I think that's how it'll work. So let's run that and see if it's all good. Oh, I forgot to, okay, so apparently I'm doing one too many there, which actually that sounds correct. So if we'll break out from here, and we also need to do this. So if not is positive, then quotient times equals negative 1. Okay, now let's run it. Okay, so we got 3 and negative 2. So hopefully that's all that needs to be done. So let's copy this and put it into LeetCode. We'll double check with the test cases, which came back correct, and now let's submit. Okay, we've got a wrong answer. So dividend 1, divisor of 1, outputted 0. Okay, so we need to change this while it's less than or equal to. Yeah, we'll do that. Okay, cool. That still returned the correct answer. So it while less than or equal to, and we'll do while greater than there. Now submit. Okay, we got something wrong. Negating the minimum value of two complements number is invalid. Okay. Didn't think of this. I guess we need to do a check to see if dividend is the lowest int possible, because we can't turn that to positive, as the positive one is this, is -1. Bool is min equals dividend equals int.min. So we have that is min. If is min, we will do dividend equals int.max, and we'll have to do math or adding 1 to it or something. Not too sure. I have to play around with it. Same, could be the same for divisor. Actually, I was just thinking, what if divisor is negative int and dividend is positive int? I'd have to do something there. Okay, we need to also check for that. So we need to do a check for both dividend and divisor. So if either of them are the min, then we change it to max, and we do it like that. I guess we could add a check here if divisor is min, and so the divisor is the minimum. If the divisor is the minimum, then it must return 0, I think. If divisor is 0, then we also do a check for if is min, but return 1, otherwise return 0. Because if the divisor is the lowest possible number, the only way that you could return 1 is if it was equal to or greater. So the only way it can be greater is if, or it's not possible for it to be greater, because the positive ones will always be lower. So the only way you can return 1 is if it's the exact same or higher, but the only way it can be is if it's equal. So we do that. So if both of them are min, return, and then we don't need to do any more down here. We can just do this. So we've got the divisor, fine. Now if the dividend is the lowest, need to do a check. Guess the check right, we're not currently doing plus equals here, but we're not checking to see if it goes greater than, actually total, we can just make it a double. I think that works, just making it double. Actually, yeah, we could just use doubles for this instead of using ints. That makes it easier. Yeah, okay. We're going to remove this. Okay, well that makes it easier. Okay, we'll do double there. And if quotient is less than int 32.max min value, that is what we will return. Else if it's greater than max value, we return max value. Otherwise we convert.int32. Let's run this here first and see if that works before we put into LeetCode. So the first one runs, but then the second one doesn't. Not sure why that is. Might just be my Visual Studio messing up, but let's do breakpoint. Okay, it does go wrong somewhere. Restart it, go there, and we'll go to the next one. And we'll just step through. Well, total is 0, makes it -3. Wait. Oh, I'm using the wrong values, that's why. Dividend, divisor. Oh, we also forgot to use it here as well. Okay, now that should be all good. Okay, there we go. Let's grab this and put into LeetCode. So it's saying, assume we're dealing with an environment that can only store integers within 30 sign range. It might be that we can't use doubles, but I'm not sure. I'm hoping it just means the value range. So it's like, if you're using something like Python, it doesn't have, you can use whatever number values. So I think, hoping it's, yeah, okay. I'm hoping it's just telling you not to use those values greater than. You have to return one of those. Okay, let's submit. Negating, still got the same issue. Okay, well, we'll just grab these numbers and put it into here. Okay, I see what the issue is for this one. I thought that would have covered this though. Okay, let's go down to here. Okay, I should probably change these to doubles and then do that. Is that the issue? Okay, I think that was the problem, but we should probably add a check for if the divisor is 1. So if divisor equals 1, and we'll just copy and paste this into it, because that took way too long because it has to just plus 1 over and over. So with this number 2147, yep. Oh, actually need to include this as well. So if it equals 1, go down to here. That'll make it negative. Oh, that's because it's both negative, both of the numbers are negative, right? So that'll just return int max value. I think that's all that has to be done for handling the larger numbers. So let's grab that and we will copy it back into the LeetCode. And just to make sure, okay, we've added that as a case, so let's run it. Make sure we're getting the correct expected output. And we did. Now let's submit. So time limit exceeded, but it's not saying what the numbers are. Maybe, I'm not sure what that could be. Like why, wait, it's saying all of them passed, but it's not giving what failed. Time limit exceeded. That's not very useful. You know what, I might need to go look up what's going on with this one. So I guess I'll be right back. So I haven't been able to find a proper solution as to what's going on here and why I can't see the actual numbers being used, but I did come across a solution to make this more efficient, which is kind of cheating as I should be doing this by myself, but if I'm getting time limit exceeded with this solution, then I have to do something else, and I wouldn't be able to figure out a way to make this more efficient without looking it up. So the way you make it more efficient is by using bitwise shifting, which is basically shifting the bits to the right a bit, which is essentially multiplying it by 2. And this is a way for you to get the multiples more quickly. So currently we're just doing 1, 2, 3, 4, 5 for the quotient, but with bitwise you can do 1, 2, 4, 8, 16, etc. and you get up to a point where it's now greater than the dividend, and then you reset it and then you start again with the remaining amount. So I'm just gonna walk through how what changes need to be made. So first of all, we'll just get rid of this. We will use double divisor. So while this is less than the dividend, we then need to do double temp divisor. We're going to be doing the bitwise shift on this. So we'll make this value, and we're going to be creating an int multiple. This is going to be holding, equals 1. This is going to be holding the amount of multiples that the divisor can be within the dividend. So we can remove this part outright. We then do another while loop in here, which is temp divisor, bitwise shift 1 is less than or equal to the dividend. Oop, don't know what happened there. Okay, why is this not giving? Okay, so it turns out we can't do it on doubles, but can do it on longs, I think. Yep. Okay. And then we'll need to convert to long. I assumed you could do it like that. We'll just long. Okay, so while this is less than the dividend, we then just shift it by 1, which is multiplying by 2, and then the multiple here we also shift by 1. So I guess to read through this, while the divisor is less than the dividend, this means that no matter what, you can get a multiple of 1 in it. So that's why we initialize as 1. Then in here, if temp divisor bitwise shift 1 is still less than 1, we bitwise shift 1 of the multiple, which is multiplying it by 2, so then no matter what, the divisor can be in there twice. But then if we bitwise shift again, and it's still less than, that means the divisor can fit into the dividend 4 times. So that's why we bitwise shift. So it's essentially just doing multiplication without doing multiplication, because we're using our bitwise shift. Okay, so we do that until temp divisor is now greater than this. Then what we do is get the divisor, and we minus equals the temp. So this temp divisor here is the greatest number of the current divisor that can be that can fit into the dividend. So we remove this from the divisor, and then we also quotient plus equals multiple, and then with that we just carry on again. So I'm not sure if this will work because I haven't tested it yet, but let's run it. Okay, returned a wrong value there. So first things first, I'm gonna, just so we can properly see what's going on, I'm gonna remove this and we will breakpoint through it. Okay, let's go to here. So DBL dividend 10, divisor 3. We go in, get the temp divisor, which is 3, multiple equals 1. Then we temp divisor 1, which would make it, would that make it 6? Yes, it would, I think. So it'll be 1, 1, 0. Then we're making it 1, 1, 0, 0, which is, yep, so 2, 1, 0, 3. Then it'll be 4, 2, 0, 0, 6. So go through here, temp divisor is now 6 down here. And then the multiple is now 2. So we do that again, but then it's not less than or equal to. I must have done something wrong. So we get the divisor, because yeah, this should be 3. Actually, let's just run through and see what happens. Okay, that makes it -3. That doesn't seem right. But let's just see what's going on. So DBL divisor is less than, turn into a long -3. We go here, makes it -6. Okay, this doesn't, okay, that's not right. Let's quotient, keep it as that. Actually, we'll change this to int, and we'll do if int, if quotient equals int 32 max. We can then do this part there. No, that doesn't make sense. Change that back to double. Okay. Don't know if we'll do anything, but let's just change it so everything is long instead of double. And we'll see that here. No need to cast it there. You know, as it's no longer DBL, we'll just call it abs, as that's what we've done to it, to absolute. Okay. Actually, I just thought, so we will do, we'll do if is positive, if int 32.max value. Actually, yeah, we'll do the quotient stuff in here. So if quotient is greater than int 32.max value minus multiple. So I was trying to do it quotient plus multiple was greater than this, but that's not how that would work. We need to do it the other way around, because then if this is greater than this, then this plus this would be greater than this. We then return this. Otherwise, quotient plus equal multiple. Then we can do the same thing in here. If quotient is less than min value plus multiple, we then return the min value. Otherwise, negative int multiple. Should this be should that be an int? Oh, we'll keep it like that. And then down here, should just be able to return this, right? Don't know if I need to do any of that, but let's just run. I want to see what happens. That did not work at all. Okay, what happened? Oh, that's right, it's doing... It's not working as I thought it would. Change that to int there. Oh, this is meant to be dividend. That's what's going on. Okay, now let's run it and step through it to see what's happening. So, divisor is 3, multiple is 1, temp divisor is now 6, multiple 1. Doing bitwise of this is now greater than abs dividend, so we exit from that. Abs dividend minus temp divisor makes it 4. Same question plus equals 1. Oh, sorry, 2, because it fit in twice. And go back here. The divisor is still less than, so we go here. Temp divisor is 3, dividend is 4, so doing this would make it greater than, so skip that. Then you do minus equal, which will make it 1, and the current multiple is 1, so that will make that 3. We go then here, it's no longer, or the divisor is no longer less than dividend, so we exit from that, and the quotient is 3. So let's continue. Yep, it's now returning the expected output. Oh, it's taken a long time to do this, but I think that's finally it. So let's copy that. We will put that into LeetCode right here. I think I deleted this curly brace then. Okay, let's run on the test ones just to make sure, and now submit. Wrong. Okay, so let's put that into the test here. 2, 2, and expected output should be 1. Let's run that, turning 0. So let's go through it and figure out what's happening. So it should return 0 there, which it didn't, which is good. So quotient 0. Okay, this should be less than or equal to, that's the problem. So we'll go back to here, put the equal sign, submit. Oh, and there we go, we finally did it. Took quite a lot of attempts. Oh, I didn't realize I've been out for an hour. But we've done it, and although I wasn't able to figure it out myself, I've now learned what bitwise shifting is, how it works. It's basically just shifting all the bits to the left one, and works as a multiplication of 2. So if you can't multiply or divide, you can use this to bitwise shift. So that was the 29th LeetCode challenge called Divide 2 Integers. So if you like this video, make sure to like and subscribe.